A laser beam strikes on point A of a spherical segment made of glass with index of refraction n equal 1.5. The radius of the whole sphere is r equals 8 centimeters. The distance from striking point A to point E equal A equal to 3 centimeters. Angle AED equal 90 degrees. The distance from center C to the bottom side of the spherical segment is B equal to 3 centimeters. Angle CFD equal 90 degrees. If the incident angle θ1 on point A equal 25 degrees, what is the angle θ4 when emerging from point B? θ4 is the angle between exiting beam and the normal line, CB. Attention, depending on the value of incident angle θ1, point D, this point B, could be on the left or right of point F. You should decide which of the following graph to use. So this is one graph. If this angle is larger, then point D would be on the right side of F. But if this angle is small, then point D would be on the left side of F. So there are two possibilities. This is one possibility. There's another possibility is this. So point D is on the right side of F. So you need to decide the D point, where it is, either on the left F or on the right of F. So given, what is given? Given θ1 θ1 equal (25°). And A equal 3 centimeters. And B equals 3 centimeters. And N, which is index of refraction of the glass, 1.5. The radius equal 8 centimeters. Then the question is find θ4 equal to what? θ4. Solutions. Solution. We define some angle. Let angle EAC equal to Z. Angle CAD this theta 2. An angle ADE ADE equal to y. An angle EDC equal to x. An angle DBC equal theta 3. And distance from point A to D equal P. And distance from C to D D. So let's label the angle. EAC equal to Z. EAC equal to Z. This angle is angle Z. EAC equal Z. CAD equals C2. CAD, this angle is theta 2. ADE equal to y. ADE equal y. This angle is y. ADE equal y. EDC equal to x. So this angle is x. Angle DBC equals theta 3. DBC equals theta 3. Theta 3. AD equal to P. AD equal to P. This distance P here. CD equal to D. CD equal to D. CD equal to D. This distance to D. For triangle AGC cosine Z A plus B divided by R. Therefore, Z equal cosine inverse A plus B divided by R. and this equal cosine inverse A equal 3 plus B equal to 3 and R equals 8. So this one equal cosine inverse 6 divided by 8 cosine inverse 41.41 degrees. And next step, I use Snell's law on point A. Snell's law on point A I have 1 time sine theta 1 equals 1.5 sine theta 2 and theta 1 equal 25 degrees. So sine 25 degree equal 1.5 sine theta 2. Zero point 42 1.5 sine theta 2. So I have 0.4226 divided by 1.5 equal sine theta 2. Zero point 2817 equal sine theta 2. Therefore, theta 2 equal sine inverse 0.2819 . 16.36 degree. So what we did, we apply Snell's law on point A. N1 is equals 1 times sin theta 1 equal n 1.5 times sin theta 2. This is Snell's law. And next step, I apply triangle AGC. For triangle AGC. So GC equal A plus B times tangent Z. Therefore, EF equal GC equal A plus B times tangent Z. Three plus 3 times tangent Z. Z equal 41 degree. $5.292. And ED A tangent Z plus theta 2 3 times tangent 41.41 plus theta 2 equals 16.36 degree. $4.758. Now, therefore, EF is greater than EF is greater than ED. Now, so EF is greater than ED. Therefore, the D point is on the left side. So this graph is good. For triangle AED, angle Y equal 19 degrees minus Z plus theta 2. And this equal minus my Z (41.41 degree) plus theta 2 equal 16.36 degree. So this equal (19 degrees minus 41.41). So this number equal 32.23 degree. Now, so here it is. Angle Y equal 19 degrees minus Z and C2. 19 degrees minus Z and C2 together, so equal to Y. And cosine Z plus theta 2 A divided by P. So I consider triangle, this triangle, AED, A divided by P equal cosine Z plus theta 2. Therefore, P equal A divided by cosine Z plus theta 2. A equal to 3 cosine Z equal 41.41 degrees plus theta 2 16.36 degree. So this value P equal to 5.625. Next step, consider triangle A ACD. I use law of cosine. D square equal R square plus P square minus 2RP cosine C2. Therefore, D equal square root R square plus P square minus 2 times RP cosine theta 2. I substitute the numerical values in this equation. R equal 8. So 8 square plus P is here 5.625 minus 2 times R equal to 8 times P equal 5.625 times cosine theta 2 equal 16.36. Now I have D. Now, next step, we consider triangle CFD. So CFD CFD. This angle is x, and this angle is 180 degrees minus x. So I have here is sine 180 degrees minus x equal b divided by d. If I substitute number, so sine so therefore 180 degrees minus x equal sine inverse b divided by d. B is given 3 divided by D we calculate here 3.046. So this 80.03 degree. Now I have 180 minus x, so therefore my x equal the angle x equal 180 degrees minus 80.03 degree. .97 degree. Now I have angle x. I consider triangle ADC. ADC, I used the law of sine. So ADC, the law of sine states that D divided by sine theta 2 equals this R divided by sine x plus y. So I have here is D divided by sine theta 2 equal R divided by sine x plus y. I call this equation as equation 1. Next, I consider triangle CDB. For triangle CDB, I use law of sines. D divided by sine theta 3 equal R divided by sine y plus 180 degrees minus x. So we use this triangle. For triangle CDB, D divided by sine theta 3, D divided by sine theta 3, D divided by sine theta 3 equal R, this R divided by sine this angle. This angle is the angle from red line and the dashed line. Because law of reflection, if this is angle y, this also equal to angle y. And this angle equal to 180 degrees minus x. So together the whole angle is y plus 180 degrees minus x. So this y plus 180 degrees minus x. Now I write down this as R sine 180 degrees plus y minus x. I move this 180 in front of y. Now I use one formula. This formula. This is a trigonometry identity. So sine 180 degrees plus any angle alpha equal minus sine alpha. So sine 180 degrees plus angle equal to minus sine alpha. So therefore, this one equal R divided by minus sine y minus x. And next step, I use another trigonometry identity sine minus alpha equal minus sine alpha. This means that sine function is odd function. And by using this property, I get R divided by sine y minus x. I change sign, I get x minus y. And this one I call this one as equation 2. So from equation 1 and equation 2, I will have another 2 equations. From equation 1, I have d divided by r equal sine theta 2 divided by sine x plus y. And this I called equation 1 prime. And from equation 2, I have d divided by r equal sine theta 3 sine x minus y. This one I call equation 2 prime. Now, from equation 1 prime and 2 prime, I have sine theta 2 divided by sine x plus y equal sine theta 3 divided by sine x minus y. Therefore, sine theta 3 equal sine theta 2 times sine x minus y divided by sine x plus y. So sine theta 2 I have already (16.36 degree) and time sine x minus y, x equal 99.97 degrees minus y I have 32.23 degrees. So divided by sine x plus y, so 99.97 degrees plus 32.23 degrees. Zero point 28 the other side I got 0.9255 and the bottom 0.74 0.3519 and then therefore theta 3 sine inverse 0.3519 equal 20.61 degree. Now on point B, I apply Snell's law again. I apply Snell's law. So 1.5 times sine theta 3 equal to 1 times sine theta 4. (1.5) sine theta 3 1 time sine theta 4. So that means 1.5 sine theta 3 equal 20.61 degrees equal sine theta 4. 0.528 equal sine theta 4. Therefore, theta 4 equal inverse 0.528. (30) 1.87 degree.